Hey guys, Mr. T here, just doing a solutions video to your Year 10 Science Chemistry practice test. So to start off with, I'm marking all of yours. I noticed there was an error here. It should be 19 electrons in potassium. So I'm going to show you answers for this question if you try to do it with 11 electrons or if you try to do it with 19 electrons from the periodic table. Okay, so just make a note of that. I've made sure the real test doesn't have any errors like that, but here there was an error in the practice test. So electron configuration for a potassium atom. Let's do the 11 electrons first. That would be 1s2, 2s2, 2p6, and 3s1. And so if you're drawing the electron configuration, I wouldn't want to see 11 protons. Yeah, and see, because of that error, that would have stuffed you up and you wouldn't be able to do the right number of neutrons, so I'm not going to write anything there. So there would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. 11 electrons, assuming the 11 electrons error from the test. Now 19, so if you went to the periodic table and you fixed it up, that would be 1s2, 2s2, 2p6, 3s2, so up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 plus 6 would be 12 plus 6. That would be 18. We're almost there. So 3p6, I've got the electron shells filling sheet next to me. So I'm looking back at that. I just want to double check the order. I don't remember it, and I'm not expecting you to. So the shells fill in 1s, 2s, 2p, 3s, 3p, and 4s. So I need one more. 4s1. So then this, if I was doing the drawing, that would be 19 protons. Look at the periodic table. Look at the mass, 39. So it would have 20 neutrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, one more shell, 19 electrons. Alright, so that's the first one. Apologies for the error in the test, but I've shown you the two possible results that I would accept, assuming the error and not assuming the error. So now, atom has an electron configuration, 1s2, 2s2, 2p6, 3s2, 3p4. How many electrons is that? That's 16 electrons. So what group would it be in? If you look into the periodic table, 16 electrons, so there'd be 16 protons. The atom with 16 protons would be sulfur, and that's in group 16. So group 16. What element's most likely to be? Sulfur, just like I said before, because you're looking at the periodic table. Metals like lithium and beryllium are very reactive because they have many outer shell electrons and readily lost. Well, if they had many outer shell electrons, they wouldn't be readily lost. They have a few outer shell electrons and they are readily lost, so that's correct. They readily lose their electrons because they only have a few of them, so it's easier to empty their outer shell than to fill it up. For an atom of sulfur has 16 protons, 16 neutrons, and 16 electrons. Which of the following statements is incorrect about the atom of sulfur? It's got an atomic number of 16. Well, that can't be the wrong answer because it's got 16 protons, so it would have an atomic number of 16. The atom would have no overall electrical charge. It's an atom, so it doesn't have any electrical charge. It would be in group 6, maybe. Let's check the last one. It would be in period 3. It is in period 3, so this must be the incorrect answer. It would be in group 6 is incorrect. Magnesium, Mg, is in period 3, group 2. Which of the following elements would have properties most similar to magnesium? Elements react with other elements because of interactions between their outer shell or valence shell electrons. So elements are similar when they have the same number of valence shell electrons. And how do we tell whether they've got the same number? They're in the same group. So magnesium is in group 2. Calcium is also in group 2. So it would have similar properties to magnesium. The horizontal rows in periodic tables are known as periods, and they contain elements with the same number of outer shell electrons. That can't be, because elements with the same number of outer shell electrons are in the same group, not the same period. Periods, and they contain elements with the same number of electron shells. So this must be it, because the other two options are groups. And that's not what the horizontal rows are. Okay, so that's the first page done. Moving on. So here, marking your practices. I notice people are making little silly errors here and there. Really, the mass number, you just have to remember that that's the number of neutrons and protons added together. Okay, the periodic table, you can use that, but remember that's the most stable version of the atom. And that doesn't show isotopes, and isotopes can change the mass number. Alright, so neutrons and electrons. And firstly, we know it's an atom, so the number of electrons will be the same as the number of protons in the atom. Alright, so that helps us decide that the number of protons is 18. So the atomic number is going to be 18, and 18 plus 16, 20, and what is 8 plus 6? 8, 9, 10, 11, 12, 13, 14. 14, so 20 plus 14 is going to be 34. The atomic number of 18, so it's going to be in group 18, period 3, and its electron configuration is going to be 1s2, 2s2, 2p6, 3s2, and 3p6. Okay, next, a lot of people were fooled by this one. You need to count this. You need to count it properly. Some people can't count to this number, 5 plus 2 plus 2 is 9. Some people tell me 7 for some reason, okay? So that's 9 electrons there. You don't need to write that. I'm just writing that to help myself out. So it's got 9 electrons, so it's going to be 9 here. It's going to have matching protons, so it's going to be 9 protons there. So the mass number is going to be protons plus neutrons. 9 plus 11 is going to be 20, so that's correct there. And then the atomic number, sorry, it's not going to be 2. The number of protons is the atomic number, so it's going to be 9 there. Okay? And so the atom on the periodic table that has an atomic number of 9 is F. That's in group 17, and that's going to be in period 2. Potassium, 19 protons. So how many electrons it's going to have? We know it's going to be 19 electrons because it's an atom. Mass number is 38. We've got 19 protons. So 38 minus 19 is also going to be 19. So 19 neutrons. Electron configuration, 1s2. That's 2. 2s2. That's 4. 2p6. That's 10. 3s2. That's 12. 3p. That's a 3. That's a 3, people. 3p6. That's 18. And then 4s1. It's not 3d. 3d isn't filled before 4s. So 4s1 to make up the 19 electrons. That is in group 1, period 4. Oxygen 2 minus, so that is an ion. It's going to have an atomic number of 8. because oxygen is 8. So it's going to have 8 protons. It's got 10 neutrons, so 8 plus 10 is going to be 18. How many electrons does it have? Okay, so this is where you need to think. It's an ion. It's a negative ion, so it's got too many electrons. It's going to have 2 more electrons than normal because it's a 2 minus ion. So normally it would have 8 electrons because it's got 8 protons, but it's going to have 2 more. It's going to have 2 more electrons than normal, so therefore it's going to have 10 electrons. So its electron configuration is going to be 1s2, 2s2, 2p6. It's in group 16 on the periodic table, and it's in period 2. Beryllium 2+, so that is an ion. It's a positive ion, so it's going to have 2 less electrons than normal. Beryllium has an atomic number of 4, so it's going to have 4 protons. 4 plus 6 is 10, so that's correct. Electrons. So normally it would have 4 electrons, but it's a 2+ ion, so it's going to have 2 less electrons than normal, so it's 4 minus 2, it's going to be 2 electrons. So its electron configuration is going to be 1s2, and then it's going to be in group 2, period 2. That's how you should think through that table, okay? Write the electron configurations, 1s2, 2s2, etc., and draw the electron shell diagram of the elements listed below. So carbon. Carbon is 6. So, symbol, protons, it's going to have 6 of them. Neutrons, if I look at the periodic table, it's got a mass of 12, so 12 minus 6 is going to be also 6. So then draw the electron configuration. Draw the shell diagrams. 1, 2, 3, 4, 5, 6. Now write the electron configuration. So 1s2, 2s2, 2p2. 1, 2, 3, 4, 5, 6. So that's carbon done. Chlorine. Chlorine on the periodic table is 17. So Cl, it's going to have 17 protons. Look at the mass. Subtract 17 from that mass, so it's going to have 18 neutrons. That beeping is the washing machine, apologies. So it's going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17. 17 electrons. Now let's do electron configuration. 1s2, 2s2, 2p6, 10, 3s2, 3p5. So that's chlorine. Electron configuration and electron shell diagram. Moving on. Sorry, that was Sammy. He may be running around during this, and I may yell at him. Calcium. So calcium on the periodic table. Calcium is, I believe it's 20. Yep, I just checked the periodic table there. So calcium, please stop. Hey, 20 protons, 20 neutrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, hey, 18 electrons, 19, 20 electrons. Electron configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 6. So how many we got? 2, 4, 10, 12, 18. 4s2. I'm going to leave all this in. How about that? So that is calcium done. Calcium 20 protons, so 20 electrons, and the electron configuration done. Write the electron configuration, draw the electron shell diagram. So the same thing as before, just before, but for ions now. How do I know it's an ion? Because it's got brackets and it's got a charge. So oxygen normally is 8. But it's an ion of oxygen that's 2 minus 8 minus 8. And it's going to have 2 more electrons than normal because it's 2 minus, so it's going to be 8 plus 2. It's going to have 10 electrons. Okay? So let's draw that. Oxygen. It's going to have 8 protons. It's going to have 8 neutrons. 1, 2 electrons. Oop, he's making a noise. 3, 4, 5, 6, 7, 8. That's normal oxygen, but it's got 2 more electrons, 9, 10. It's going to have 2 more electrons than normal, so it's going to have an overall negative charge. So I need to indicate that it's an ion with brackets, make it 2 minus, and then now I'm going to do the electron configuration of 1s2, 2s2, 2p6. And you can see it's got a full outer shell because it was closer to filling up because it was a non-metal. Magnesium. Magnesium normally is 12, but it's got a 2 plus charge, so it's got 2 less electrons than normal, so minus 2 is going to be 10 electrons. So I've chosen these examples because I wanted to show you that they're completely different ions here, but they've got the same electron configuration. But what makes them their element is the number of protons inside. So magnesium, protons is going to have 12, neutrons is going to have 12, and now let's draw the electron shells. 1, 2. Hey, stop jumping. 1, 2. 3, 4, 5, 6, 7, 8, 9, 10 electrons. But it's supposed to have 12, so it's not balancing out the 12 positive protons in the nucleus, so it's going to have an overall 2 plus charge. So let's do the configuration. 1s2, 2s2, 2p6. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 electrons done. I'm just going to close the door and stop that washing machine. Right, I'm back. Next page, draw an electron dot diagram to show the formation of covalent bonds in a molecule of methane. So, I noticed in marking this, only the top of the class were able to remember us doing this. If you can show me that I didn't do this, you can go to my boss and tell them. But I showed you P1 to P6 in one of them. I believe it was P6 or maybe P5. But we talked about covalent bonds and we showed the idea of an electron dot diagram. Electron dot diagram only shows the outer shell of valence electrons. So in carbon it's got 4 valence electrons. Hydrogen has 1 valence electron. These are metals. These aren't metals. These are both non-metals. So they don't give and take electrons and form ions like ionic compounds. These are covalent. So covalent means they're sharing their electrons with each other. Carbon wants 4 to fill its outer shell. Hydrogen wants 1 to fill its outer shell. So instead of giving and taking, they're going to share their electrons so that they have full outer shell. So carbon's going to go in the middle, and it's going to have 4 electrons surrounding it. And then there's 4 hydrogens here because it says H4 hydrogen, and it's got 1 electron to share. Hydrogen up the top, and it's got its own electron to share. Hydrogen on the left, it's got its own electron to share, and hydrogen on the bottom, it's got its own electron to share. So now you can see that because there's sharing happening, carbon is going to have 8 electrons in its outer shell where does the 4 extra come from? They come from the 1 electron that hydrogen's sharing with it. And these hydrogens, they all have 2 electrons. Where's one of those electrons coming from? It's coming from carbon's 4. It's sharing one of its carbons with each of the hydrogens, so that hydrogens have 2 electrons in their outer shell. So it's happy too. So then change the 2 dots to a line, as indicated in the lesson. So now you show covalent bonds with a line, and it's going to look like this. Alright, so that's how you show the formation of covalent bonds in a molecule like methane. Atoms that have more or fewer electrons than protons are called ions, yes. How do I know that? I told you that. Explain why metals lose rather than gain electrons to form ions. Metals have few outer shell electrons, so it is easier to lose the Sorry, back again. Metals have few outer shell electrons, so it's easier to lose the electrons to achieve an empty outer shell. Next, explain why nonmetals gain rather than lose electrons to form ions. Nonmetals have many outer shell electrons, so it is easier to gain the electrons to to achieve a full outer shell. Done. Anything similar to that is acceptable. Write the electron configuration for the chloride ion. So chlorine, where's my periodic table? Chlorine has 17 electrons normally, but it's a 1 minus ion, so it's going to have 1 more electron than normal, so plus 1. It's going to have 18 electrons. Okay, so electron configuration, 1s2, 2s2, 2p6, we're up to 10, 3s2, 3p. So normally it would be 5 because of chlorine being 17, but it's got 1 more electron, so it's going to be 3p6. Write the chemical formulas for magnesium fluoride, aluminium sulfide, lithium chloride, calcium oxide. So here you use the ion tables. You will be provided this. Ion tables. Look for magnesium. Magnesium is Mg, and it's got a 2+ charge, but I don't need to write that. Okay? All I need to do is put little numbers to the right and at the bottom of these to make sure that there's the right number of the ions to balance out the charge. Fluoride is F minus, so it's only -1. Mg is +2, so I'm going to need 2 fluorides to balance it out. So it's going to be MgF2. Aluminium sulfide. Aluminium is Al. Sulfide is S. But aluminium has a charge of 3+. Sulfide has a charge of 2-. So they don't even each other out straight away. The lowest number both of the 2 and the 3 charges go into is 6. So if I had 2 aluminiums, I'll have 6+, and if I have 3 sulfides, I'd have 6-. So Al2S3. Lithium is Li, and it's got +1, and chloride is -1, so they both balance each other straight away. Calcium is 2+, and oxide is 2-, so they balance each other straight away. This question, you're using the ion tables again, but backwards. You have the formulae now, you just need to name them. Now, I had a lot of people breaking it up into nitrogen, hydrogen, chlorine. No. Your table has NH4, which is ammonium. And your table has Cl, which is chloride. So it's ammonium chloride. Mg is magnesium, just like before. Then I had some people breaking it up into carbon and oxide and all this other stuff. No, CO3 is carbonate. Look in the table. Ki. K is potassium. I is iodide. Fe is iron. If you want to be particularly specific, this particular ion that we're using is iron 3 because it's got the 3 plus charge. And OH is hydroxide. Why do I need 3 hydroxides to balance it out? Because it was iron 3. How do I know that it was iron 3? Because I needed 3 hydroxides, which are all -1. So that would be an overall -3 charge from those 3 hydroxides. Question 14. State 2 properties of non-metals and 2 properties of metals. I'm going to have metals here. Ductile, meaning I can stretch it out. Malleable, meaning I can hammer it down. That's how blacksmiths deal with it. Ductile, malleable, conduct heat, conduct electricity. You could talk about usually solid, mostly solid at room temp. Okay, but any of those, any 2 of those is fine. Non-metals, brittle. Heck, I forgot shiny for metals. Brittle, not shiny for non-metals. Do not or don't conduct heat. Don't conduct electricity. At this level, we're being very simplistic and we're saying don't, okay? Like in all walks of life, there's always exceptions, so there are exceptions to non-metals that do conduct electricity in certain forms. Alright, and the last question, draw and label a diagram of the structure of a metal and explain why metals are generally good conductors of heat. So I think people forgot this because it was just part of one of the presentations. I didn't do a whole presentation on the structure and a diagram of metals, okay? So use this opportunity to understand it now. So metals, we've already said that metals don't hold on to their outer shell electrons well. So metals actually are an arrangement of metal ions, positive because they lose their electrons, arranged in a 3D lattice. So regular arrangement. Okay, and because they don't hold their electrons very well, there's a sea of electrons floating around them that are loosely held. Okay, if they were too loosely held, the metal would be a liquid and it wouldn't be solid like most metals are. But they're held in some way. Okay, so I'm going to draw an arrow here to metal ions, and these are electrons. And I've done an arrangement like that, a regular arrangement to show they're in a regular 3D lattice. I just haven't done it in 3D. So metals have metal ions arranged in a 3D lattice with a sea of weakly held electrons. If you are asked what the structure of a metal is, that diagram and this sentence sums it up. Okay? Now we need to work out or explain why they are good conductors of heat. Well, the electrons are weakly held, so they're free to move. The electrons are quiet. I like using the word quiet. Makes me sound classy. The electrons are quite free to move, so they can freely transfer their heat. Now remember from last year, heat is actually just kinetic energy. Heat is a measure of how much the particles are vibrating. Okay? And if they're vibrating and they're free to move, they can transfer that vibration from one to each other, and that allows the heat to propagate or conduct across the metal. So free to move, so they can freely transfer their heat kinetic energy from one to another, therefore conduct heat well. Okay, so there's your explanation for the diagram structure of a metal and why they conduct heat well. There's a similar arrangement for conducting electricity. Electricity is just the flow of electrons, okay? And because these electrons in a metal are not strongly held, they're free to flow, so they're free to conduct electricity. Alright, so just checking down here, I believe that's the last question, so that are the solutions. Those are the solutions for your Year 10 Chemistry Practice Test. Hopefully that helps you out. See you in the next video.